Soil compaction, common to construction projects, increases the strength and stability of soils to support earthworks, structures, and pavements. Standard test methods to achieve maximum soil density for the anticipated loads, whether those loads will be static or dynamic, can be performed to measure the dry density and moisture content of the soils and thereby predict the adequacy of construction compaction efforts. Soil moisture density relationship test is a laboratory determination of the maximum dry unit weight and optimum water content for different soil types used as engineered fill. The sand cone test method, rubber balloon test method, and nuclear density test method are three common field tests that, when compared to the laboratory proctor test results of the same soil, a ratio of percent compaction can be determined that is reliable and accepted by infrastructure design teams and regulatory authorities. Let's compare these three tests. The sand cone test is an accurate and reliable ASTM and AASHTO test method that requires the use of a sand cone apparatus such as the Gilson HM100 sand cone density apparatus. Simply stated, the test is carried out with the apparatus and sand. The weight of the sand-filled jar and the cone are determined. A small hole is excavated on site, and the sand cone apparatus is placed onto its base plate and over the hole. The stopcock is opened to allow the sand to fill the hole. The excavated soil and the apparatus with the remaining sand are collected, recorded, and calculated using the appropriate ASTM test specifications for a specified density or percent of maximum density. The pros of the sand cone test are: it has a long history of accuracy and reliability. It does not require extensive training to perform or regulatory licensing for use. It's cost-effective, and equipment and materials are not hazardous. The cons are that the sand cone test requires 30 minutes or more to complete. Nearby heavy equipment must pause during testing. It is generally limited to unsaturated soils, nor soft or friable soils. And all excavated material must be carefully recovered for accurate testing. With the rubber balloon test method, an on-site hole is excavated with the soil carefully collected and set aside. A balloon density apparatus, like the Gilson HM66 or HM67 balloon density apparatus, is positioned over the hole. But instead of using sand to measure volume, the calibrated vessel is pressurized, forcing the rubber membrane into the hole. Graduations on the vessel are read to determine hole volume. The weight and moisture content of the excavated soil is recorded and calculated using ASTM soil moisture test specifications. Pros of the rubber balloon test are: it has a long history of accuracy and reliability. It does not require extensive training to perform or regulatory licensing for use. It's cost-effective. Multiple tests can be performed without changing density media. And equipment and materials are not hazardous. The cons are that the rubber balloon test method requires 15 to 20 minutes to complete. Balloon membranes can puncture during testing of soils with appreciable amounts of rock or coarse material. It is generally limited to soils in an unsaturated condition and is not recommended for soils that are soft or that deform easily. And all excavated material must be carefully recovered for accurate testing. The nuclear density test method measures soil density using a nuclear density gauge that emits radioactive particles and a detector that receives the particles that are either reflected by the test material or passes through it. Nuclear density gauges are typically operated in one of two modes: the more reliable direct transmission mode, where a retractable rod is lowered into a pre-drilled hole, or the backscatter mode, where the rod stays within the instrument. The pros of the nuclear density test are: density and moisture tests are completed in a few minutes. Nuclear density gauges can incorporate data logging and location reporting functions. It is an optimum test method for large projects requiring many tests per day. Density and moisture content are automatically computed by the nuclear density gauge, and the test method can be used for a wide range of soils. The cons of the nuclear density test are: nuclear density gauges are expensive. There are multiple regulatory requirements that govern usage, transportation, and handling of nuclear material, including monitoring of nuclear density gauge operators for exposure. Operators require advanced safety training and certification. Nuclear density gauges can be sensitive to harsh environments, and readings are sensitive to excessive voids within the testing area. As we can see, each of these different test methods have advantages and disadvantages. The most important factor for proper earthwork installations is the expertise of materials testing technicians, equipment operators, and project superintendents. For any questions about soil compaction or for any Gilson product, please contact your Gilson Technical Support team.